Hey everyone, and welcome to our actual demo and giveaway video. The Hakko unit will be really eligible for people in the US. Since this unit can be quite expensive to ship overseas and it's only a 110 unit, I thought it was best to just limit that. Everything else will be pretty much for anybody globally, so if you want to put your name in, go right ahead. When you subscribe and leave a comment, please let me know your location so that I have an indication of who's eligible, and then we'll pick people at random so they can receive these. We have a really nice pair of micro nippers here, and I love these things. They're about a $17 pair, but they work really well. They're almost as good as a $50 pair. Nice soft grip, nice long handle with good action, and very sharp edge, so you'll be pleased with these. And a couple pairs of tweezers. You can never have enough tweezers, and I've been very happy with these Vestas brand that you can get off of eBay. They're quite cheap, they work well, and they actually hold their points quite well even if you drop them and stuff. So I figured somebody will be pleased to receive those as well. We also have a bus pirate that's originally designed by Ian Linné from Dangerous Prototypes, but this is a SparkFun version of them. They all work very similar though, so I find this to be a very useful unit. I use it whenever I'm prototyping a new SPY or I2C chip, and you can just get up and running really quick to be able to get into there and figure out how they communicate and get data out of them. So whoever gets this will find this to be very useful. So let's kind of get started on the next part of this video, which will demonstrate how you set this unit up. There's a few little gotchas when you first get it if you wanted to use the presets or change from Fahrenheit to Celsius, and I'll show how we do that. After that, we'll do a brief demo on how to solder this RS-232 to USB breakout board, which also has headers for which also has headers for an XB chip to fit into there. When you first get these units and power them on, they're actually set to kind of a default mode where you don't have access to the temperature presets. And that might be pretty much okay for most people, but I actually happen to like to use the temperature presets. And I also wanted to cover this in case you are a person, say in Canada, that ordered one of these from the US and it's stuck in Fahrenheit. So I kind of wanted to show you how you can change the temperature over to Celsius or some of the other options. So when you get the unit, you want to hold up and then turn power on the unit. And this is going to put you into the parameter setting mode. From here you have 4 different parameters that you can adjust. The first one is your temperature display in Fahrenheit or Celsius. So if I click on it, it says that we're in Fahrenheit, and I could push up and change it. I'm going to leave it in Fahrenheit for now because that's what I'm used to, although I don't mind using Celsius either. The next option is our temperature warning. So if we turn the iron on and it's on and heating, but it doesn't display a temperature higher than this temperature, then we know there might be a problem, and it's basically going to alert you to that. We're not going to mess with this right now, so I'm just going to go through it. The one we do care about, and this is the 11 parameter setting, this is our preset, our temperature mode. Are we going to be in normal temperature mode with only one temperature, or are we going to be in preset mode? So I'm going to get into here and adjust it. So we're in normal mode. I'm going to change it to preset mode, and then it's preset so we can see, but now I'm going to adjust how many presets we have. I'm going to use 3 presets for this unit, and I don't think we really need more than that. I'm going to set for 600, 650, and 716 on this, and that should be adequate for most things that people are going to use for it. So we go into here. We don't need to adjust this one, so we'll kind of cycle back through it. Now we can just hold enter for 2 seconds, and it's going to ask me to confirm yes or no. Now you can press up to say no, but now I'm going to confirm yes. Okay, so all the settings are set right now, and we should be able to adjust our presets. So we have 3 presets now. Now we have to go through and set the actual temperatures on these. So we're on preset 1 here, And we need to adjust the temperature for preset 1. Now we're going to press the enter button and hold it. And then, as you can see, we can cycle through the different things. So, here we go. So we're on preset 1, which is 600. And that's the one we want. That's 600. So we'll go to preset 2. We'll enter. And we want to adjust this one to 650. So let's hold enter for 2 seconds. And then we're going to adjust this. You just count to 6. Go to the next one, 50, go to here, and then there. That's good. Now we set preset 2, and as you can see, it's going to ramp down. So let's go to preset 3, enter, and now let's set this one for about 716, 720, something like that's fine. So we're going to hold and enter, and then we'll go to the next one, and then we'll just change that to 720 is fine by me. Okay, so now we have our preset set up on this unit. As you can see, that really wasn't that difficult to do. As I said, they actually made the 2-button interface fairly intelligent, and I like how they have the parameter settings on this. So, as you can see now, it's really easy to set between your temperature presets, and in a way, it's almost as quick as using the analog version of this. So, most of the time, I'm going to be in parameter 2, and that's 650, because that's my preferred soldering temperature, is 650. So now we can actually do demo and soldering with this unit. I also wanted to kind of show that you not only can you solder on a circuit board, but you can also actually create quite nifty little you can also build pretty nifty little creations here. This is a project that I made for Maker Faire Bay Area this year as something that would just catch people's eyes on my booth. And basically it's just a welding wire that I've clipped, bent, and soldered together to form 2 different half cubes. One's the ground and one's the positive rail. And then I use capacitors to hold them together everywhere. And it just really consists of a microcontroller, GPS, real-time clock, and a humidity with a display and a driver for it. But I just kind of wanted to show that if you think outside of the box, you can create some kind of analog Jim Williams-esque designs, and they're quite fun to build, actually. One of the gotchas with this is its display is actually a common cathode, but the driver is a common anode. So I had to reverse everything, and it was quite a juggle to get everything working in the firmware there, but it turned out quite well. Okay, let's get started with the demo portion here. I just wanted to briefly go over the tools you need. It's real simple. All you need is really just a pair of tweezers, your good soldering station, some flux. I prefer to have 2 different types, the flux pen and also some tackier flux. And of course then you'll need all your components. In this case, the board we're going to build is pretty simple. It's just one FTDI chip. And also the other main IC is of course the 3.3 volt regulator. Everything else is LEDs or other passives and the USB connector. There's also a PTC here which acts as a kind of a fuse there to help protect the USB. So how I would get started on building this is I'd pretty much start with the smallest parts here, and we'll go ahead and mount the passives and the LEDs first, and then we'll mount the voltage regulator, and then we'll kind of finish up with the FIDI chip there and the USB connector. So I'm going to get the soldering iron powered up here, and it's on its 650 setting that we did earlier. So we're up to temperature. So the very first thing I'm going to do with my iron, as I always teach this, is there's this big blob on there. I'm going to clean that off, right like that, and then there's still a bit on there, but I'm going to add some more, and then I'll clean that off quite aggressively, and then I'll just put a little bit more on there just so we have a fresh batch while I get some stuff ready. Then I'll get my tweezers, and then I'll place one of our first LEDs on there, making sure that we have it facing the correct way. Actually, I believe this was our power LED. So. And the way I usually do this is I'll use my bare solder end as kind of my holder on this. It's kind of hard to see as we'll get in there. But then I'll get my iron out and I'll clean it off, and I'll rely on just the little bit extra I have left. And then I'll touch it onto the pad here. And I want to make sure on the chisel tip to use kind of the flat side down so I get the best heat flow. And then I'll just apply just a little bit and let it flow into place. And then you pull off real quick, and as you can see, it kind of falls into the right place. And then you can spin your board a little bit and then go up to the other side of it there, and you just kind of finish up by touching the other side. And then there, that part is soldered. And then always, I'd like to finish up. We're going to apply our solder onto it, clean it, and then repeat the process of putting solder back onto it and place it onto the stand. That way we keep our tip in the best possible shape. And then you just simply repeat with the next part. So we'll grab another LED, making sure we place it the correct way. And we can place this one up here and then repeat the process with that. So we take the iron out, clean off the excess solder, and then you make sure you have your flat edge down, and you just touch the pad and the part kind of at the same time, and then just add just a little bit, and then it'll flow. There you go. I like to just kind of spin the part around and then finish soldering it on the other side. If you're using lead-free solder, you're going to need to use a lot of flux on this. I'm using a leaded solder with a rosin core flux, so it makes soldering quite a bit easy, as you notice here. I don't really have to use flux on the passes, but I will on the ICs just to make it easier for me. So we can do the next part and go ahead and grab our other LEDs here.
Place them down. Place this one down. Oops. And then solder those. And always I've been keeping my tip clean. So we'll place it down. There we go. Okay, and then spin around here. It's okay that first one isn't straight, I don't mind. Some people do mind about those things. If you do mind, you can always use your higher station to fix it up. Looks like I might need to flux that one just a little bit. Yeah, that's fine. There we go. Okay. Now, we'll go ahead and place our PTC. We can go ahead and solder that right now too. As I said, this guy acts as just a little fuse. Its resistance goes up as its current goes up. So if you draw more than, I think it's 500 milliohms for a substantial period of time, I think it's like a couple hundred milliseconds or something, it'll start increasing its resistance. So you'll see there's a lot of USB circuits. Okay, that one is done, so as always I'm going to go ahead and tin it, clean it, and then tin it again, and then put it back into the stand.
Okay, so now we can get some of our other passives, and in this case I have a kind of a new secret weapon here. It's hard to see, but this is a reel holder, and then I can hold a bunch of parts onto it. I'll zoom out and maybe get a picture of it later, and it makes grabbing passives a lot easier, especially with a vacuum pickup tool. But for right now, I'm just going to grab parts out of it manually. And basically we just need a few capacitors and some resistors.
And one more. And there's for our 10. And then I'm just going to put 1K down for everything, just to be easier for right now. Normally for the signal strength indicator, it's a 330 ohm, and I'll just mount my 1K on there for now, since we're not going to even put the XP headers on it anyway. Okay, so I think that's enough passives for now. And it's basically the same cycle, we're just going to go ahead and place the components onto there. And then solder them. Oops, there's a little bit extra. And then we just basically, I like to hold it down. Sometimes they're really light components and you need to hold it a little bit, so I'll hold it with soldering, which will give you just enough resistance to keep them in place. And then of course you can just go to the other side and then solder it as well. Okay. I'm backwards here, so I can't see the best. Okay. I don't think I got that one secured all the way. I'm just going to turn it a little bit so I can get that angle on it. There we go. Sometimes it's tricky to get the heat onto the pad and the part at the same time. The key is just to be patient and you'll get it. Okay, so remember as always, keep adding this nice lovely solder onto there to keep it protected. And then of course we'll just add the next part. These two we'll just kind of place them. Some people like to tin the pads first, and that's okay, but the reason why I don't tin the pads is because it actually creates kind of a little hair on it, and you sometimes can't get parts in the right place. And I find it's easier on fresh soldering just to do it without tinning it at first. Once you practice enough, this is really easy to do. Just a little bit of excess solder on each one of those. I'll clean it up after we heat this side up. There we go. Okay, so we got most of the resistors mounted. A couple more capacitors and a resistor. Place this guy, of course, here. a little bit of solder. And then we can, oops, didn't have the pad hot enough in that instant. And then we'll, oops. So the key is to heat the pad and the part up at the same time so that when you touch the solder, they both flow together. There we go, and then to here. And then you also find with the ground plane, you might need to heat just a little bit longer due to the fact that the ground plane is just going to add a little bit more thermal capacity that you have to fight. So now we can kind of switch sides here and just finish up. Oops. Kind of just jumping back to either side, trying to get them both heated up equally. I kind of botched that one. I'm sorry for the camera shake. Okay, I just wanted to make sure I had both sides of the capacitor folded. Some of these aren't the best joints, and I'm not happy with them. So what we can do is we can just go through with our solder width and clean those up just a little bit. Usually you can kind of just touch and drag off. So we'll go through on each one of these here. Touch and drag, touch and drag. And that's okay, there we go. Yeah, some of my soldering isn't the best, I apologize for that. But in the end, if the part works and your project is working, then that's what's important. You want to spend more time soldering it than you do prototyping it after all, of course. So the last thing I need to do is get one of our bigger capacitors out. And we'll place him down. Just like that. Now he's a little bit more tricky to solder because he's a bigger guy, and sometimes he likes to get stuck on the iron, just like that. So you definitely want to hold it with your solder. And then flip the other side, and then you can clean up the actual solder joint. There we go. Okay. Let's try to get a little bit of that head. There we go. So that was that trick kind of where you heat both sides up, and then you can move it around. You can do that with almost all of these small components, just because they're so small and they don't have much thermal mass to it. Okay. Yeah, it's not the best soldering job, but it'll get it done. I'm kind of out of practice, to tell you the truth, because I do a lot of reflow now, because it's so much easier. But when you don't have a reflow oven set up and everything, it's kind of difficult. So the next thing we're going to do is place down our 3.3 volt regulator and our USB connector. Put with these, and for 30 chip, we want to use a little bit of flux.
Okay, I like to use a little bit of a tackier flux on some of this stuff, so I'll just put a little bit down on these pins here, and of course on the fitty chip, as it'll just make it a little bit easier to work with, and we can always put a touch on there. It also helps hold the ICs down. So if you're having trouble with them moving around, flux will help hold them in place a little bit since it's tacky. And we'll grab our USB connector and place it in. There's little holes that it goes into place. The only thing really with this, you want to make sure that you make the USB to serial chip is mounted in the correct orientation. As you can see, there's the circle indicating that. And of course you want to make sure your placement for the pins is pretty accurate. So we'll get our iron out and clean it off well. And one of the things I like to do with the USB is simply hold it down with one of these, just a kind of a tack, just to hold it into place. And then we're going to line up our USB as accurately as we can to the pins, and then tack it into place on one of the pins. Something like that. On this end it looks pretty good, so I'm going to add a little bit of solder to my iron here and tack these first couple pins. There we go. And then I'm going to check the other side, and it looks like it's a little bit off, but we can push it into place. Then we'll tack that. You can see it's a little bit off, so I can adjust it just a hair. And that looks pretty good. It's a little bit to one side, but there's not a problem. We can make that work. Now that we have it tacked, I can tack it onto one of the opposite corners here, and then I can go to this one and start drag soldering. So what I'm going to do is clean off any of that in case it's oxidized, and put fresh iron on, or fresh solder on the bottom of the iron, and then I'll just take it and then drag it down the pins. Now you'll see there's going to be a little bit of excess at the end, but if you clean your iron off and drag a couple pins up and then quickly pull it off, you can usually get most of it off, or at least onto the last pin. So then we'll go to the other side and then fill in just a little bit of iron or solder on our iron. And then we'll do the same thing. We'll just heat it and then drag them down. Okay, clean it off, and then you can grab the last couple pins and try and get it at least onto the last pin. So there's that. The only other thing we need to do here is attach our voltage regulator and our USB connectors. So just heat the pad up, add a little bit, heat the pad up. You can also drag solder these too, but since there's only 3 pins, it's kind of hard to get it tacked into place. So there we go, there's that. And then I'm going to drag solder those pins in there. I'm just going to add just a little bit, not much on this, because we don't want to bridge any of those. And then you just get in there and kind of drag it back and forth just to make sure they all get soldered properly. Okay. Yeah, it looks like that'll work. It's not the best job, but they're all soldered roughly. Sometimes you can add just a little bit into them too if you need. There we go, that's better. There.
I'm going to clean off my iron, and I'm going to finish up soldering the pads that hold the USB connector. These are actually the mechanical holds that hold it to the board. You want to make sure those are soldered quite well, so it doesn't rip off. And that first one we tacked, add just a little bit more. Okay, now that's pretty much done. I'm going to clean it a little bit, and then we can plug it in and test it, and then we should get some LEDs lining up and getting our pretty chip is communicating. The next thing we do is just check real quick to make sure there's no solder bridges. And we look like we're okay there. Yeah, I mean there's some bad soldering on there for me, I'm not happy with it, but we'll go ahead and go with it. What I'm going to do is get out one of my coffee filter papers and my pump bucket here, and then I'll just fill up with a little bit of solder with one of my horsehair. Then I'll fill up with one of my horsehair brushes, and then just clean all of our excess flux off. This will also tell you if you have any sharp solder joints, because it's going to tear, and then that can tell you to go back and clean those up, and then you'll be able to do a final physical inspection on these, and just to make sure that nothing is obviously wrong with it. So we'll just finish cleaning off some of that excess flux that got out of there, and then plug it in and test it. It's important to take that last step and clean out everything on there, and then if you really want, you can soak these like I showed in the other video. I think that'll be good enough to test it. So, I'm going to get out one of my parchment octopus cables here, and then we'll just plug it in and see if it lights up or blows up. Look at that. We got power, and it didn't blow up, so that means we are communicating, and I'm happy with that. Okay, we got power, and it didn't blow up, nothing feels hot. We got voltage, and so.
Okay, so I think that goes ahead. I think that gives a good demo of the Hakko in action. I'm very pleased with the iron and generally overall. I didn't need to change any of the tips. That was the default 1.6 millimeter chisel tip, and it was able to solder this board no problem. And if I really needed to, I could drag solder the RAM chip on this. I don't think we need to actually do that demo, since this one demonstrated quite well how it works, even though some of my soldering wasn't quite on. Other than that, I hope you all enjoyed the video, and please give me a thumbs up, and don't forget to comment and subscribe, and to leave your location so that you can be eligible to win some of these things I'm giving away. So thank you for watching, and I hope you enjoyed these videos. Bye.